Hello humans, welcome to this video about the Perpetuum motor and its development. In the last video I have explained the four main equations for quantum gravity until a point where we where I've explained that this value here must be minimal and this value must be maximal, because this is high, then this is low, and because this is high, this must be low, and this is high again. So this means for the microcosm, the asymptotical freedom of the mass is high. So for the macrocosm, the asymptotical freedom of the mass is low. Then this is low. Okay, it's low, and we need here a low value for the extreme case that an object falls into a black hole. And this is the extreme that we consider in this moment. This here must be for the macrocosm. Here we can choose between both possibilities. Fg asymptotical free is taken here. It is minimal. This means the mass of the object that falls into the black hole is attracted by the gravitational field of the black hole and not by the electromagnetic border of the universe as both a condensator property of the coordinate system of the universe and the system of a north and a south pole that we have for the coordinate system of the universe. And this belongs to the mass attraction of the border of the universe. Regarding the magnetic monopole and the conductivity of micro-black holes for light, as the analytical conductivity of micro-black holes for magnetic fields. Okay, we have here now this value is now low, minimal. This means the mass is attracted by the black hole and not by the coordinate system of the universe. But this here is more complicated. I have to explain. It's more complicated. I will explain in another lecture what means the correlation between mass and magnetism, or the correlation between charge and electromagnetism, electrostatic field. It is much more complicated. So okay. So, and this value is high for an object that falls into a black hole. This is maximal. This is for one extreme maximal and for the other extreme minimal. An object, and therefore we consider this equation, the free energy equals E times EP squared, and this follows to the this we can multiply out, and then we will see that this depends here on the wavelength lambda, which is here inside, and also on the mass. And we will see that as lower as the wavelength lambda, the macroscopic resonance wavelength, as higher is the free energy. And the free energy is this is the Helmholtz free energy. This is now squared here. Temperature This is maximal for asymptotical free motion, and this is minimal for absolute coupling, an object that falls into a black hole, for example, or regarding charge, an object, decayed material, decayed particles fall into the nucleus. So this, the free energy is max, and this belongs to this coupling here, which is an E by lambda. This is maximal here for coupling. So with this formula, we can see that we can make a conclusion about what we have here in this case. That this is minimal means that the charges of the electron are coupled on the Coulomb field for an object that falls into a black hole, for the microcosm. And what we have to know is that elementary charge is minimal in the case of an object that falls into a black hole in the macroscopic object. This is new. Imagine that the Earth has an elementary charge as a whole and is attracted by the border of the universe. No. Where is it? Wait. Where's it going? Where's the picture? The picture is away. Picture. I don't have it saved. Where have I saved it? No, I haven't saved it. Okay, then the picture is gone, regrettably. But imagine now that we can do also the opposite and say that for asymptotically free motion, for tunneling of gravity, this value is minimal. That means the object for gravity, here's the first equation, that means the mass is not coupled on the gravitational field of the black hole. The mass is now asymptotically free from the gravitational field because the mass is now vanished from the macrocosm into the microcosm, into the particles. So, and this means this value is high. This means that the charges in the microcosm are now asymptotically free because they are attracted by the coordinate system of the universe, while the masses of the microcosm are attracted by the masses of the nucleus. Or the case of asymptotically freedom. And in this case, F macro coupling is minima, and the free energy squared for asymptotically free motion is maximal. This means for asymptotically free motion, and as for the Perpetuum mobile, the lambda here inside, this EP, must be minimal to increase here the free energy. As higher is the mass of an object here, inside this, As higher here is this mass, or this mass, as higher is the free energy. This means as higher is the mass, as better works anti-gravity, as better works the Perpetuum mobile. Imagine a large spaceship like the big Enterprise. It's very large. It is good because as more large it is, as better is anti-gravity. But we have also to consider that we have to adjust lambda here. It must not be simpler if the spaceship is more large. I don't know, we have to see. But in the moment it is more important to develop the free energy mode. Okay, we have seen that this value must be low for asymptotically freedom and high for coupling if an object falls into a black hole. And we have seen that an object is either attracted by the coordinate system of the universe, either for the microcosm or for the macrocosm, or it is attracted by masses or charges. So the coordinate system of the universe or the masses or charges. This is constraint forces, and this is asymptotically free forces. If something is attracted by the universe, by the coordinate system of the universe, then this means, imagine this room here, and I imagine this is the whole universe here, this space in this room in which I am now, and I move this hand from here to here, then this hand moves into this direction there. This is the coordinate system of the universe. But at once, the hand is moved here because it's heavy in this moment. It is moved backwards. It wants to fall to the center of the universe. This is a coupling. For the coupling case, I have the energy table. I have to explain it more. The energy table that I have developed says that we have, for example, here the value 1 and the value 10 to minus 68, and here the value 10 to 68, and here the value 1. Here we have 10 to minus 34 for this free energy, and here is 10 to 34. That here in the middle we have about the energy, the kinetic energy of the Earth, we can see. And the habitable zone hangs together with this value. And here we have a balancing between coupling regarding this reference frame, because we have an orbital system. Regarding a reference frame system, it is more complicated, but we have here a balancing between coupling on gravity and asymptotically freedom, because an object turns around the sun, but not. We have to consider the reference frames here also, but this we can say this line has these truths inside, and we have for an orbital system here the opposite. Both cases, coupling and asymptotically freedom as a balanced system. And here we have either coupling on gravity or asymptotically freedom. Both have the values E. And here also, they're both the same values, because this and this is on the same point. We will see later. Okay, bye. Thank you for listening to this lecture. Bye.